So hello everyone, welcome back to our channel known for knowledge. Yes, so again I'm actually back with an interesting chapter, that is light, reflection and refraction. So this is a very important chapter from the examination point of view, and as well as this is going to be a very interesting chapter also. So very much is actually there in order to remember from this chapter also. And actually we are going to solve some numericals today. We are also going, so okay, before we actually start, I know that it is already night, 10:30 it's already 10:30 time, but still actually I want to make this live video because you can actually access this even afterwards also. You can actually access this video. So for that reason only I'm actually making this live at even 10:30 also. And actually I'm actually thinking to close all the live videos mostly by tomorrow. So by tomorrow I'll try my level best to upload the last I don't say the last live video, but about this all the lessons I'll try, that will be the last video. Okay, about that will be the last live video that we are actually going to see. I'll try to see if I can do both reflection and refraction today. Otherwise the reflection part I'll do today, and diffraction part tomorrow, and federalism part tomorrow I'll do it. Federalism from civics lesson 2 I'll do it tomorrow. Okay, so that is my main aim. So let me see what actually I can do. So after that let us decide it. Okay, so then so today we are mainly going to learn about the reflection part. So why actually I'm doing all the videos hurriedly, because after 2 days I've I think tomorrow, day after, and after that also cannot upload any videos because I'm actually going out. So because of that reason only I'm actually uploading all the videos today only, now itself only. Okay, so try to understand my situation also, and that's the reason I'm actually uploading all the videos now, so that you can actually have the access to watch them also easily. Okay, so that is the reason. Okay, so today we are mainly going to learn about the light, that is a reflection part. So reflection part we are going to see, I have actually made the video in such a way that reflection is one part and refraction is one part, so that it is easily accessible to you also, and for making the video also it is easy for me also. Okay, so in the lesson that is light as a reflection, we are mainly going to see what is actually reflection and what are the different type of spherical mirrors. We are going to see concave and convex mirrors, and also we are also going to see about plane mirrors also, because plane mirrors also will actually come into the picture here only. And also we are actually going to see about the different uses of these mirrors also, and before users also we are mainly going to see about the ray diagrams. So the ray diagrams are also very much important from this chapter. So ray diagrams also we are going to see. Then image formation, how the image is actually formed. So when we actually keep the the object at different positions, how we can actually get the image, that also we are going to see. Then we are also going to see about the numericals also, how the sign convention also we are going to see, the numericals we are going to see, and the in-text questions also will solve from this chapter, that is light as reflection. So till reflection, what all in-text numericals are there, in-text NCERT questions are there, those questions also will be solving. Okay, hope my voice is also clear, right? My video is also clear, right? Yes. So with that, let us start the live video. Okay, so first, understanding what is actually light. Light is nothing but it is a sensation of vision. So light is nothing, it causes us the sensation of vision. Okay, so with that light only we are able to see objects all around us. With the help of light only I am able to see this screen also, able to see the screen also. It may be the light tube light screen, or it may be the laptop screen also. So in laptop screen also there are many minute different light sources which are actually kept inside the laptop screen, because of which only I am able to see all the image, or because of that only I am able to see the image which is actually reflected on the laptop. So therefore light is a very important source for the sensation, for the sensation of vision. So in order to view all the objects, light is a very important source. Without light you cannot view any of the objects. Therefore that's the reason light is nothing but it is a sensation of vision, which also causes a sensation of vision. That you must actually remember from this chapter. What is actually light means? It is a sensation of vision. Now let us try to understand what is reflection. Reflection is nothing. For example, you are taking a plane mirror. This is a normal. You have actually learnt about all of these things in the previous 9th class. In the 8th class you have learned, but still, actually I want to revise all of them so that you are thorough with the topics. Okay, so you think this is a surface plane mirror. Now I'm actually drawing a normal. Normal is nothing but it is a line which is drawn perpendicular to the mirror. Normal is a line which is drawn perpendicular to the mirror. So when a line is actually striking the plane mirror at the point of incidence, this is a point of incidence. Okay, this is called as a point of incidence. Okay, now what is happening here? So this is the incident ray. It is striking the mirror at the point of incidence. So the reflected ray is here. Okay. So now what is happening in the plane mirror or in any kind of mirror, if you see, what happens is that the incident ray will actually strike the mirror and it is bouncing back. So what is happening? It is not changing the medium. It is actually coming back to the same medium. If you see here also, this is air medium only. Here also it is air medium only. Just the light is reflecting. Just the light is striking the mirror and it is just reflecting back. So in that kind of a situation wherein the light is just striking the mirror and it is just reflecting back, that is called as a reflection. So what is actually the reflection is nothing but whenever a reflection definition is asked, you should write like this. So the bouncing back of the light ray after striking any any smooth surface or smooth mirror is called as reflection. So if you see an incident ray, so this is an incident ray which is actually striking the mirror, and this is a reflected ray which is actually after striking, which is actually bouncing back, which is actually bouncing and it is actually going back to the same medium. This is called as reflection. This is the incident ray, reflected ray, and this is called as normal. Okay, so the angle between the incident ray and the normal is called as angle of incidence. Angle between the normal and the reflected ray is called as angle of reflection. That you must remember, very very important. Okay, so and it is always said that angle of incidence is always equal to the angle of reflection. Okay, this is very much important. So this is the second law of reflection. So in reflection also we have two main important laws. In that, the first law will actually tell us that the incident ray, the reflected ray, the incident ray. So if you see, the second law of reflection is actually stating that the incident ray. So if you see the second law of reflection, the incident ray, the reflected ray and the normal are actually lying on the same plane. That is the first law of reflection. Okay. Then the second law of reflection will actually tell us that the incident ray is always equal to the reflected ray. That is a very important. So that is the angle of incidence is always equal to the angle of reflection. This is a very very important law which you must remember. So what are the two laws of reflection? When they are asked, you should write the first law of reflection as the incident ray, the normal and the reflected ray will lie on the same plane, at the point of incidence. Okay. And what is the second law of reflection means? You should write angle of incidence. That is angle of incidence is always equal to the angle of reflection. This is very much important. This is very much important to remember from the examination point of view also. Okay. I think now you got an understanding, right? What is actually reflection? What is actually the laws of reflection also, right? Now let us go in detail and understand about the different concepts. And this table is not that important. Okay. Not required to remember also. Okay, now let us see the rectilinear propagation of light. Rectilinear propagation of light is nothing but the light ray will always travel in a straight line. If you see, if any light ray also, if the light ray, you think this is the torchlight. Okay, torchlight. The light rays are actually coming here from different directions. Okay, now what are happening? They're always traveling in a straight line with respect to that light ray. Okay, they're not like coming like this and not going like this. No, it's not like that. No, they're always traveling in a straight line. So like this, they are always traveling in a straight line. So that is called as a rectilinear propagation of light rays. Okay, that is called straight line. So when a light is always traveling in a straight line, that is called as rectilinear propagation of light. But you must remember it. Okay, then still what else is given? Everything is given, right? What all I told, that is given. Okay, Therefore, the light is very much important in order to focus the light, and in order to make the objects visible to the human eye. Light is very much important. Okay. Now let us see, as I already told you, these are the two main important laws of reflection. Okay, that you must remember. Now let us try to understand what are the different characteristics of an image formed by the plane mirror. So let me do one thing. Characteristics of the image formed by a plane mirror. For example, let me do one thing. So this is a plane mirror I am drawing. Okay. So this is here the person is standing. Okay. Here the person is standing. Okay. Object is here. Object. Okay. What is happening here? You should see the distance between the image and the object, and the distance between the mirror and the object is always equal to the distance between the image and the mirror. Okay, this is image is formed here only. That means let us take the object distance as u and image distance as v. Object distance is nothing but the distance between the mirror and the object, that is called as object distance. Image distance is nothing but the distance between the image and the mirror, that is called as image distance. So these both are always equal. The first characteristic is nothing but object distance is always equal to the image distance. Okay, that you must remember. The second most important characteristic is nothing but the size. The size of the object is always equal to the size of the image. For example, if the object is around this much of size, then the image will also be this much size only, right? If the object is of 10 meters height, if the object is 10 meters height, then the image will also be 10 meters height. So what you actually conclude, the size and the height of the image of the size and height of the object is always equal to the size and height of the image respectively. That means height of height of object is always equal to height of image. This is very much important. Third one is it is virtual. Virtual in the sense that if you see the image which is actually falling on the mirror, can you actually capture the image? No, you cannot capture the image because it cannot be taken on the screen, and you cannot capture the image because it is a virtual image. Therefore, the objects which are actually falling on the mirror are virtual and erect. Erect means it is as it is. Erect means it is as it is. And upright is nothing but it is upright. For example, sometimes what is happening is this person is there like this. Sometimes this person is there, and you're in the mirror also appearing like this one. That is called as erect. Your hands and legs are down only, and the image is also down. So like this. Okay. But sometimes what happens is you are like this. No, that means your hands and legs are facing downwards. But what happens? You'll come upright. Upright in the sense like this. It will come like this. So this is called as upright. Okay, which you must remember. Okay. So sometimes will come like this. So this is called as upright. This is also one more important characteristic of an image formation. Characteristic of the image formation by the plane mirror. Okay, we have seen three things. First is object distance equal to image distance. Next one is about height of the object is equal to the height of the image. And next one, the image formed is virtual and erect. And the fourth most important thing is it is laterally inverted. Laterally inverted in the sense that if you raise the left hand, it appears like it is actually raising right hand. If you see the image also, now I am actually raising my right hand, but you are actually up, but for you it is actually appearing like I am actually raising your left hand. So that is a lateral inversion. That means the left appearing right is called as a lateral inversion, which you must remember. Okay. Okay. Now you got an understanding, right? What is actually, so all the points which actually I told you are included here. Okay, so you can just go through them. So as you know, the different properties or the characteristics of the images which are found by the plane mirror. Okay, so all points which I told you are there included here. You can just refer them. Now let us try to understand what are actually the mirrors. So there are actually some kind of mirrors wherein the reflecting surface is curved inwards or curved outwards. So what are those kind of mirrors? For example, now let us take a spherical mirror. So spherical mirrors are kind of mirrors wherein the reflecting surface is curved. Okay, the reflecting surface is kind of a curved. That means generally the mirrors are generally like this, straight. But these kind of mirrors, but there are also some specialized mirrors wherein they are actually curved like this. And which are actually curved. So those kind of mirrors which are curved inwards or outwards is called as a spherical mirror. Okay. Now let us try to understand what are the different type of spherical mirrors. We have two different type of spherical mirrors. One is a concave mirror and one is a convex mirror. So in a concave mirror, what is actually happening is, so if you take a concave mirror, this is a concave mirror. The reflecting surface is curved inwards. The reflecting surface is there. See, for example, you take a spoon. Okay, a spoon is the only one which will act like both concave and convex. You take a new spoon, not a used spoon. Okay, used spoon will lose its shining capacity. So and also different kind of particles will get accumulated on that. So don't take that one. Take a new spoon. You take the new spoon and you keep the normal facing side, not backwards, front side. If you keep the curved surface, if you see, it is curved, right? That is called as curved inwards. It is curved inwards, right? So if you see, this is a spoon, so this is the smooth side. This smooth side is here. So if this is a smooth, right? So the curved surface, this is curved inwards, and outwards it will be rough, but inwards it will be smooth. Spoon, it is not like that, but I am telling about the concave mirror. In concave mirror, the inwards are smooth and outwards are rough. So that way you can actually imagine. Okay. So that is called as a concave mirror. As a convex mirror, the kind of mirror is wherein the reflecting surface is curved outwards. For example, this is a mirror. The reflecting surface is outwards. For example, now you take the spoon again. Spoon outside is outside. If you see, this is bulged outside, right? This is bulged outside, and that smooth surface is curved outwards. That is called as a convex mirror. So by taking the example of the spoon, you can easily understand the topic. Okay, that you can do it. Okay. Now let us try to understand about the reflecting surface. You got an idea, right? What is actually the concave mirror and convex mirror, right? So concave mirror, the reflecting surface is inwards. Convex mirror, the reflecting surface is outwards. That you must remember. Very, 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 very important. Okay. Now let us try to understand what is actually the pole. Pole is nothing but it is a geometric center, or it is the center of the reflecting surface of the spherical. If you take, for example, you are taking this one. For example, you are taking this much. This much curved surface you are taking. Now this is considered to be the center, so that is called as a center. So the center of the reflecting surface is considered to be the pole. So or else the geometric center of the reflecting surface is considered to be the pole. Okay. From pole we are actually drawing one line. Okay, that line. So okay. Whereas now let us talk about center of curvature. Center of curvature is nothing but, if you see here, this is a concave mirror, because if you see, this is also. This is curved outwards. So this is a curved inwards. See, for a concave mirror, once again I'll draw the picture. For a concave mirror, it is curved curved inwards. That means smooth surface is curved. So this, if you see this kind of lines, that means that side it is rough. So if you see nothing on one side, that means that side it is smooth. That you must, like that you remember, concave. It will be easy for you. Okay. So if I draw even like this also, even if I draw like this also, you must actually remember, concave is in the sense means the rough side is outwards and smooth side is inwards. But like that you have to remember. I forgot actually. Whereas convex is nothing but, if you see convex, I'll draw like this. What is happening in convex? In convex, the reflecting surface is outwards. So therefore the rough surface will be inwards. So rough surface is inwards and reflecting surface is outwards. Therefore, in reflecting outwards, if you see, nothing is there, nothing lines are there. Therefore, that side is smooth. Whereas inside, if you see, lines are there, that means it is rough inside. So therefore, like that you have to remember, this is convex. Okay, like that you remember. Forgot actually. Okay. I draw in the beginning. Actually, I have drawn a wrong figure. That now you can actually understand it. Okay. Now let us try to understand. What is actually the center of curvature. Center of curvature is, if so, what is actually happening is, if you take the picture, if you take this figure, it is actually a part of a circle, right? So if you take, so this is actually, it can actually form a circle. If you see, it will actually form a circle. So this one also, if you extend it further, it will actually form a circle, right? So the center of this circle is actually considered to be the center of curvature, and this center of this circle is considered to be the center of curvature. So that is very much. So if you see here, so the reflecting surface of the spherical mirror forms a part of a sphere. The reflecting surface, if you see, it is actually forming just a part of a sphere. It is not a complete sphere. It is just forming a part of a sphere. And for that sphere, it has every sphere is actually having a center. So that center is considered to be the center of curvature. It is represented with C, and pole is represented with P. Okay, but like that you can remember. And pole and center of curvature are generally same line. Okay, so the line which connects the pole and center of curvature is called as principal axis. So this line is considered to be the principal axis. So the why it is considered principal axis, because it is actually joining the pole and the center of curvature. Okay, now let us try to understand what is actually the principal focus. Principal focus is very much important. So this principal focus is nothing but, it will be different for concave and convex mirror. So the definition of principal focus for a concave mirror and a convex mirror is different. Why it is different? Let us try to understand it now. Because now let us see first for the concave mirror. So this is a concave mirror. Reflecting surface is inwards. That means rough surface is outwards. Okay. Now this is pole. So this is pole. This is center of curvature. Okay. Now when the light rays are actually striking the mirror, they'll actually meet at one point. Okay, when the light rays will actually meet at one point, that point is called as principal focus. So the principal focus of a concave mirror is nothing but when the light rays will actually strike the concave mirror, they'll actually meet at a point. That point is considered to be the principal focus. Okay, but for a convex mirror, what it will happen? Let us see now. So anyway, whichever you can draw like this one, you can like this. Both the ways are same. Okay, just you have to not get confused. So for your understanding, you can draw it one way only. Okay, but whichever is convenient. Okay. So for a convex mirror, if you see the reflecting surface is outwards, so the rough surface is inwards. For a so this is, I'll draw the picture. Convex. See, for a convex mirror, so it is always, you have to remember that the light rays for a convex mirror are always diverging. For the concave mirror, the light rays are always converging. So if you see the light rays for a concave mirror, they'll actually meet at a point, right? They're trying to meet at a point. Okay. Whereas for a convex mirror, what is actually happening means they're meeting at a point, that is focus. Whereas for a convex mirror, they're actually diverging. and what happens is that they'll appear to meet at focus like this. So when extended backwards, they'll actually appear to meet. So if you see here, so when extended backwards, they'll appear to meet at focus. So therefore, for the principal focus of a convex mirror, you have to write like this. So when the light rays will actually strike the convex mirror, they appear to meet at a point. That point is considered to be the principal focus for a convex mirror. So you have to understand it. You have to understand in that way. Okay. So the convex mirror is not the principal focus of convex mirror is not what when the light rays will actually strike the mirror, they appear to meet at one point. That point is actually considered to be the principal focus of a convex mirror. They'll appear to meet. They do not meet. Whereas for a concave mirror, what happens is the principal focus of a concave mirror is actually nothing but when the light rays will actually strike the mirror, they will meet at a point. Perfectly, they'll meet at a point. That point is considered to be the focus, principal focus of concave. So they'll appear to meet, and here they'll perfectly meet at a point. Appear to meet. So after this, so that is the principal focus of a concave mirror and convex mirror respectively. So with that we actually complete this one. So if you understand, if you see this figure, then you will easily understand. So light rays are actually meeting at a point, that is focus. Whereas here they are actually trying to meet. That means they are actually appearing to meet. So that is called as principal focus of the concave mirror and convex mirror respectively. Okay. And now let us try to understand. I forgot one thing, that what are actually the real and the virtual images. So real images are the kind of ones which can be taken on the screen. That means we can actually capture the real images. Okay. For example, if you take the movie theaters also, we can actually capture the movie real images. So in movie theaters we actually use from backwards, the light will actually come and it will actually fall on the screen. So that is a real image. Okay. That is a very good example of an example of the formation of real image. That means can be taken on the screen. They cannot be taken on the screen. Okay. For example, the image formed by the plane mirror. Okay. Second point is that the real images will actually they'll meet at a point. Whereas virtual images will actually appear to meet at a point. Third most important thing is real images are inverted. Inverted in the sense is nothing but they are always upside down. Okay. For example, if the image is like this, means they'll actually come like this. Okay, so that's what happens in the movie theaters. They actually try. So the video which they have is a reverse image. So therefore, when they're actually trying to appear it on the screen, it will actually come perfectly. That you must remember. And the virtual images are always erect is nothing. They'll always be as it is. As it is in the sense the image is straight. They'll also be straight only. Okay, so I'll draw the image. For example, you draw an image example also. If you draw an examples, so for drawing, you will not get extra marks, but the presentation would be nice. Now you can actually impress the teachers also with your presentation. So image is like this means object is like this. So object is like this means image will be like this. Whereas image is straight means object also will be object and image both will be straight. You can actually remember like this. So this is a very important part you have to remember. Okay. Now let us try to understand the image formations. How we can actually form the images. Before we actually go to the image formations, one important topic is actually left out. That is the focal length. So what is actually this focal length? So if you now you got an understanding, right, what is actually the focus? So the distance between the pole and the focus, or the distance between the focus and the center of curvature is considered to be f. So f. That means, so for example, and one more thing I actually forgot. So first, that is the radius of curvature. If you see, this is the entire. So if you see this, when we extend it forwards, this is actually forming a circle, right? So from the center to the any other point is considered to be the radius. So therefore, this is called as a radius of curvature. Okay. And the principal focus, this point is there, no? That principal focus point, it is actually in the perfect middle. Okay, this is in the perfect middle of the center of curvature and the pole. Therefore, this is so if you see here, this is also I'm extending. So this point, if you see here, this is a radius. This is the radius. Okay, that is called as the radius of curvature. And focal length is half of radius of curvature. That means r equal to 2f. Okay, r is always equal to 2f because this is focal length and this is also focal length now. So because of that only r is always equal to 2f. That means radius of curvature is twice of focal length. Or else you can say focal length is also equal to half of radius of curvature. So this is very much important in solving the numericals and everything. Okay, and this is very much important. Now let us try to understand what is actually aperture. Aperture is nothing but the reflecting surface is considered to be the aperture. For example, this much we are taking now, so this is considered, this much we are actually taking the reflecting surface. That is the aperture. Aperture. Now let us see the ray diagrams. So what are actually the ray diagrams? The first ray diagram. So these are the rules for drawing the ray diagram. So you must actually know what are actually the rules also. So in rules, what you are actually going to see is that when a light ray in a concave mirror, when a light ray CFP, when a light ray is actually drawn parallel to the principal axis. As you know, principal axis is nothing but a line which is joining. So sorry, this point is P is always here. Okay. So the line which is joining center of curvature and pole is considered to be the what? It is a principal axis. So a line which is actually drawn, so a light ray which is actually drawn parallel to the principal axis, after striking the mirror, it will pass through focus. That is the first rule for the concave mirror. For the convex mirror, what it is there? So a light ray which is traveling parallel to the principal axis, after striking the mirror, it will appear to meet at focus. It will appear to meet at focus. That you must remember. So it will appear to diverge from the principal focus. So if what is happening, it will pass through principal focus here, but here what is happening, it is actually trying to appear to diverge from the focus. It is actually diverging from the focus. It is actually trying to appear to diverge from the focus. Whereas here it is actually converging through the focus. Okay, whereas here it is appearing to diverge. Diverge is nothing, it is going like this. Converges like this. Diverges like this. Okay, like this. The second rule is, so first thing what we have done, we have drawn the ray. First case we have actually drawn the ray diagram. So we actually what we have done, we have actually drawn the ray diagram. We have actually drawn the light ray parallel to the principal axis. But in the second case and it is passing through focus, right? But in second condition we are actually trying to pass it through focus. Okay, a light which is actually passing through focus, after striking the mirror, it will pass through the principal focus. After striking the mirror, it will travel parallel to the principal axis. Okay, so if you see here also, in the case of convex mirror, a light which is actually traveling, it is actually appearing to travel through focus. After striking the mirror, it will try to pass through the principal axis. Okay, the third case is nothing when a light is actually passing through focus, it will strike the mirror and it will actually come back along the same path. So no direction change is actually seen there. Okay, in the same path it will actually strike the mirror and also come back in the same path. So in the case of convex mirror also, a light which is actually appearing to travel through convex mirror, after striking the mirror, it will come back along the same path. It will reflect along the same path. That is the third case. The fourth case, we are mainly going to see that when a light is actually traveling through pole, okay, so a ray incident obliquely to the principal axis towards a point P on the concave mirror or a convex mirror is reflected obliquely. So the incidentally and the reflected rays will always follow the laws of reflection at the point of incidence, making the angle of incidence and angle of reflection equal. So when they are actually passing to the pole, that means angle of incidence will always be equal to the angle of reflection. In the case of the convex mirror also same case. Okay, now let us try to see the image formations by the concave mirror. So this is a very important. So let me open the whiteboard. So this is all, so 35 minutes is already done. I think it is going to end now. So let me do one thing. end and I'll start, because this image formation is very very important. So because definitely a question is actually going to come from these image formations, so you should be able to answer it. So whatever it is, and a question is actually asked from the image form, from this is nothing but it is going to be about the image formation only. Now let us try to see the image formation now. This image formation is very 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 important. So how the image is actually formed, where the object is there, where the image is formed is very important. Okay, so first thing, first case, object is an object at infinity. Let us draw the image. Concave mirror. Let us discuss first all the cases of concave mirror, then we'll go to the convex mirror. Okay. So for drawing any image formation, for drawing the rays for the image formation, you need at least 2 rays. So 2 rays are actually mandatory in order to find the image formation. Okay. So what is happening here? So in the first case, when the object is at infinity, we don't know where the object is at, therefore we call it as infinity. So when the object is at infinity, the image is actually formed at principal focus. That means we have used the 2 ray diagram. We have actually used the 2 light rays. One is 2 light rays. So these both light rays are actually traveling parallel to the principal axis. So after striking the mirror, they are traveling to the focus. So the image is formed at focus. So where the image is formed, the image is actually formed here, that is at the focus. So here the image is formed. Then what is the nature of the image? So this nature of the image, it is going to be real, inverted, and it is also going to be diminished, highly diminished. Highly diminished is nothing but highly diminished is nothing, very 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 small it is going to be. Okay, the image which is actually formed is going to be very 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 small. Okay, that you must remember. So this is the first case. So when the object is at infinity, the image is actually formed at focus, and the nature of the image is real, inverted, and highly diminished. Means it is very very small. Okay, first we have taken the case wherein the image is somewhere at infinity, we don't know where it is there. Okay, let us start to see the second situation. Now the object is beyond center of curvature. So here we are taking 2 light rays. Okay, so one light ray is actually drawn parallel to the principal axis. After striking the mirror, it is passing through focus, and one more light ray which is actually traveling through focus. After striking the mirror, it will travel parallel to the principal axis. Okay, so in that case, if you see, these both light rays are actually meeting here. Okay, these both are meeting here, therefore the image is formed there. So where the image is formed? So the image is formed here. And if you see, the image height is very much bigger, it is very high. So that if you see, the object is much larger as compared to the image. Therefore, when we are asked about the image, the image is that, so where the image is there, so image is between C and F, that is center of curvature and focus. The image is actually formed. Okay, now let us it is formed. Now next, what happened? So after this, now the nature of the image. So nature, when they ask, you have to write image is always real, inverted, and also diminished. Diminished because if you see the image, the height of the image is the height of the object diminished. Diminished because, so the height of the object is greater than the height of the image. Therefore, the image of this form is much smaller. Therefore, we have to say that the image form is smaller as compared to the object. Okay, this is the second case. Third case, let us see now. Object is at C. See, for this, what actually is happening, see here. So when so in the third case, it is quite difficult because you have to use your own methods in order to draw this, because what is actually happening in the third case is that when the object is at center of curvature, the image is also formed at center of curvature only. So that means the height of the object is always equal to the height of the image in this kind of situation. Therefore, that is a very important case. Okay, important case because in this also questions can be asked. So when you actually go there, I'll tell you from where the questions will be asked, from this kind of, from this question, from this ray diagram. Okay, from this image formation. The object is at center of curvature. With the first ray diagram, we are first light ray, we are actually traveling parallel to peninsular axis. It is passing through focus. Again, same importantly, it will form at center of curvature. The second most important thing is, if you see the light, the ray diagram here, so the object is placed between C and F. Okay, and what will be, where the image will be formed? The image will be formed beyond the center of curvature, and the nature of the image is real, inverted, and magnified because if you see the height of the image is the height of the image is greater than the height of the object. Therefore, it is magnified. The image is magnified. This is the fourth case. Okay. Then the fifth case, let us see now. You must all remember this, very important. In the fifth case, we see first what we have done. First, we have kept at infinity. Okay, if we keep at infinity, the image is formed at focus. Okay, then the second case, what happened? So from first, I'll say from first, if you see the image is at infinity and we got it focus, right? So then in the second case, what happened? The image is beyond C, then it is actually forming at C and F, between C and F. So in the third case, it is at C, it is forming at C only. And in the fourth case, it is the object is between C and F and it is forming beyond C. Okay. And in the fifth case, what is happening? The object is at F, but the image is actually formed at infinity. So this is a very important case. That means here I'm using the third case wherein the light is actually passing through the center of curvature. So this third case I'm actually using here. Okay. So in that case, what is happening? The image is actually formed. We are actually not knowing where the image is formed. Therefore, it is at infinity. That means first one and fifth one are opposite. B1 and D1 are opposite to each other. If you remember like this, then it will be easy for you. Then sixth case is a very important case, and from this question, from this exam, from this question will definitely come. From this, mostly they are actually asking this kind of figure only in exam. When the object, so first we kept at infinity, next at beyond C, next at C, next between C and F, and F also we kept. Five done. Now we are also going to keep between F and P. The image is formed behind the screen. That means behind the screen it is formed. That means inside the mirror the image is actually formed. It is not actually formed outwards. It is actually formed inside the mirror only. So this is the only case wherein you have to remember that this is the case wherein when the image is formed behind the mirror, then it is called as a virtual case, virtual and erect. Okay, this is the only case, and the image is highly magnified. Okay, this is the only case we have to remember, that when the object is actually placed between F and P, the image is formed beyond, the image is formed behind the screen, and it is virtual and erect also. And uses of concave mirrors are also used in headlights, torchlights, searchlights and everything, because it will provide a powerful beam of light. Okay, and they're also used in shaving mirrors. They're also used for large image. Why they are used in shaving mirrors? Because here in that case what is actually happening, because the sixth case wherein the image is actually kept between F and P. So in that case what is actually done means the object is actually kept between F and P. So what is happening? So the image is actually from magnified images form, so that we can actually see properly and we can shave it. Okay, and dentists will also use a concave mirror. So that in that case situation also the sixth case is applicable, wherein the image, in order to see a magnified image, the object is actually kept between focus and pole. So in that situation the image is formed virtual and erect, and also gives a magnified image. So for that case also it is used. And for producing a heat in the solar furnaces, in that case we are actually trying to concentrate. So that means so sunlight rays are actually from infinity, right? So we are actually trying to converge all those rays together at infinity. So in that case they'll produce more heat also. Okay, that also is an important case. Because so if we convert the light rays at focus, the focus point will have more heat, therefore it will produce a burning sensation also and produce heat also. Whereas convex situation is quite different, quite same. Okay, so whereas the light rays are actually passing parallel to the principal axis, after striking the mirror they appear to form at focus. So that means the what we actually understand is here the object is at infinity and the image formed is behind the screen, and it is virtual, erect and highly diminished, and point sized also. Okay, and the second case what is happening, second case is also most asked question here. The image is actually kept anywhere. So if you see the concave mirror, we have some certain points like F is there, C is there and everything is there, but for a convex mirror we are not having any kind of points, therefore we will not use anything. Okay, we can, wherever you want you can keep actually outside the mirror. Inside the mirror you can't keep an object, right? Outside the mirror anywhere, here you can keep, here you can keep, anywhere you want you can actually keep the mirror. You will get the object between F and P, that is focus and pole only, where I'll draw the image formation. If you see here, sorry here the object is placed. Okay, it is appearing to travel through focus. Next, the fourth case I'm using. Both are converging together at this point, and the object size is very much bigger as compared to the image size. Therefore, the size of the object is greater than the size of the image. Okay, that you must. Therefore, it is a diminished image is formed. So, like that, you have to remember. The uses of convex mirror. Convex mirrors are used in everywhere. So, where we use this convex mirrors, we can use this convex mirrors for vehicle headlights also. For rear view mirrors. Why? Because why we are using for rear view mirrors? Because they provide wider appearance also. So they give a wider appearance. Because why cannot use the concave mirrors, they will also produce a wider view, because they can also produce a wider view, no? But why we are not using? Because only when the object is placed between F and P, then only we can actually get the wider view. In all the cases, we will not get the wider view, no? So that's the reason we are not using the concave mirror. Whereas for a convex mirror, wherever you place, we'll get a wider view only. That's the reason we are using convex mirrors in the rear view mirrors, in order to give a wider view, as well as in order to give a wider view. For example, why we are not using plane mirrors? Plane mirrors will only give what is as it is, only this much only, whereas the concave mirrors will give this much area. That means they are giving wider view of the area. So that's the reason we are using convex mirrors. They're also used in parking lot mirrors also. Parking lot, you know, no? In order to see where the parking space is there, in the see, in parking areas also we cannot know, will actually do not know where actually the place is there to park the car, no? So in that situation also a big mirror is actually kept, so that we can actually see where the empty place is there in order to park the car. Okay, so define the principal focus of concave mirror. Very easy question. Radius of curvature. So radius of curvature is 20 focal length. So always remember that focal length is half of radius of curvature. So 20 means 20 by 2, it is 10 centimeter. So name the mirror that can give erect as well as enlarged image. So the erect as well as enlarged. So concave mirror is the only one which will give erect and enlarged. Whereas convex mirror, it will give erect and diminished. Okay, concave. So why do you prefer convex mirror? Because it gives a wider view, whereas a plane mirror will not produce a wider view. So numericals, I try to see it complete in the next class, or the other ones we'll see it. So we'll actually end with numericals only. So numericals, if we do, then this topic is done. Okay, now let us try to see refraction. We'll see tomorrow only, because I'm also tired today. So tomorrow only we are going to see refraction. So let us try to see what is the sign convention, how we can actually identify the sign convention. Now this is very, very important case. Wherein so if the object, so if you see the first thing, the object is always placed to the left of the mirror, and this implies that the light from the object falls on the mirror from the left hand side. Okay, and all the distances parallel to the principal axis are measured from the pole. Okay, so how we'll actually know the image sign? That means sign convention is very much important, because you see we have object distance and image distance, no? So in the same case we also have for the spherical mirrors also. Okay, so if you see the image is there, so let us think that the object is here. Okay, the object is there, then the image is also here only. So if you see, the light rays are actually traveling this side. Okay, now what we are actually doing, the light rays are traveling to the mirror, but for measuring the distance between the mirror and the object, we are taking from the left side. That means we are actually going from this side. Therefore it is always taken as negative. Okay, for measuring we are actually taking it from the pole to the, we are see, if you see, the light rays are always moving towards the mirror. Okay, so in that case, so what is actually happening is the light rays are always moving towards the mirror. So but for measuring the distance, we are actually taking from the pole to the center of curvature, right? From pole to the center of curvature, or where the object is formed. So in that case it is always negative, and in that case only then the image is also formed at center of curvature. So we will actually take it from the pole to the center of curvature, then that is also negative. For example, one more situation try to show you. So you see this kind of situation. This case you see. What case you want? Let us try to see it for this case. So this case, what we are actually doing, the image, the light rays are always traveling this side. But for measuring the distance, what we are actually doing, we are taking it from the left side. So from left side, that means from the pole, we are actually taking it towards the mirror, towards the object. Then it is negative. Okay, so the object distance here, it is negative. Similarly, object distance is negative. So if you see the image distance also, you are also taking from the pole to the image. Therefore, image distance is also negative. Now let us try to see for the sixth case. Sixth case, if you see here, the object distance, the object is always traveling like this only. Like this only the object is traveling. So like this only the object is traveling. Okay. The ray diagrams are actually, light rays are actually traveling that side only. But for measuring the distance, what we are actually doing, we are taking it from the pole to the object. Therefore, this is taken as negative. Okay. But if you see actually the image formation in this case, for measuring the distance, what we are actually doing, we are measuring this side only. No, that is from the mirror to the image. Then this kind of situation, we actually take the image distance as negative. So the image distance as positive we take, because when the light rays are actually in the direction, of the image formation, then it is positive. When it is away from the image direction, that means light rays means it is negative. So if you see here, the light rays are actually done this side and they are actually reflected backwards. So for measuring the object, so for example, this is a mirror. This is a mirror, I am keeping the object here. So for measuring the distance between those both, what I am actually doing, from the mirror I actually count till the object. Therefore this away, we are actually coming away from the mirror, that is negative. Therefore in that case, we actually take the image object distance as negative. But if you see the image distance here, we are actually taking in the direction of the light rays only. That means this side only we are actually taking now. So therefore that is always positive. Like that you have to remember. Otherwise, if it is becoming difficult, means you can, simple trick is also there. Always the virtual images are positive, real images are negative. If you remember like this also, it's fine. So whatever is, this side full, whatever it is there, that is real images. So it is always negative. So this side, what that is behind the mirror, what is actually formed, that is positive. That is virtual images. Like that you can do. Now let us see magnification. Magnification is nothing but it tells us about the height of the image to that of the height of the object. That means if there is any change in the height of the object to that of the height of the image, that is called as magnification. So magnification is nothing but hi by h is actually gives rise to v minus u. So this is the formula you have to remember. And one more important formula, that is the mirror formula, that is 1 by u plus 1 by u equal to 1 by f. So this is the mirror formula you have to remember. Okay. 1 by v is nothing but image distance. So for example 10 meters means depending on the minus 10 on that, you have to remember and do it. Okay. U is nothing but object distance, f is focal length. Okay. So magnification should always be taken as minus v by u equal to hi by h naught. That means height of the image by height of the object. So if you see, the negative sign is for the real, the positive sign is for the virtual. This is very important. Now let us solve the numericals, two numericals which are actually given in the textbook. The convex mirror used as a rear view mirror on an automobile has this radius of curvature as 3 meters. So they gave the radius of curvature as 3 meters. It is located at 5 meters from the mirror. So the bus is located 5 meters from the mirror. So find the position, the nature and the size of the image. So the object distance u is equal to 5 meters. Okay. And focal length, let us find focal length is half of radius of curvature, so it is 3 by 2 meters. That means it is 1.5. Okay. Now let us draw the ray diagram for this. Okay. So the focal length is 15. So 1.5. So 1.5, this is 3. So object is 5 centimeters. 5 centimeters is nothing but where it is placed. It is placed beyond C only, no? So because till here it is 3 centimeters only, 3 meters only. So beyond C means it is here. So if the case is beyond C means where the image will be formed. The image will be formed between C and F. You have to remember the second case. Okay. It is formed between C and F. So now what you will actually observe from this, the height of the object is greater than the height of the image. Therefore, so whatever the value which you are actually getting, okay, so the height of the image will be smaller as compared to the height of the object. And also the whatever the values you are getting should always be less than 3. Should always be less than 3. So it should be in the range of somewhat 1.5, right? So 1.5 means somewhat like, so it should be greater than 1.5 and less than 3. Should be greater than 1.5 but less than 3. In that range it should be there. Okay, that you must. Then in the question they may ask you a range also. So range of curvature, it is 3 by 2. Minus 3 by 2, that is minus 1.5 meters. Whereas center of curve, so that is u is nothing but minus 5 only, because everything is in the same direction. That means it is all the real only, no? So it is minus 1.5. Then let us use the lens maker's formula. So sorry, mirror's formula. So this is the focal length. So focal length is 3 by 2 equal to 1.5 minus 1.5. So I am taking it as minus 3 by 2 only. Okay. I'm actually so what is happening in reciprocal? Reciprocal means minus 3. So this one I am actually shifting this side. So minus 1 by 5 means it is becoming plus 1 by 5. So minus is it should not be in the denominator now. It should come to the numerator. So like this it will be. Okay. Now what is happening next? Next you have to take the LCM. LCM is 15. So into 5 you have to multiply into 3. So minus 10 plus 3 by 15 equal to minus 7 by 15. So minus 7 by 15. So we'll get minus 7 by 15. You do the division. So 15 then 7. 70, no? Then 15 5s are 75. 15 6s are 15 4s are 15 4s are 60. So 0.4 you'll get. No, how 0.4 will get? Sorry, I forgot one thing. Hey, this mistake you don't do, children. So what you have to do is minus n by 15 you got, no? Here that is a value of 1 by v. In order to get the value of v, you have to take reciprocal here. So it will be minus 15 by 7. Okay? If you take minus 15 by 7, division means 2s are 14. 1 zeros are mean some kind of 1. So it will be some kind of 2.1 2.14 it is answer. Let me check once. 2.14, it is 1.15. Maybe I have made a mistake. Let me check it. Is it 15 only? So 2 will go up. done a mistake. If you find out, tell me, then everything is perfect, you know. Focal length is taken positive. Radius of curvature is taken positive. That is a mistake here. So we've done a mistake here only. I got it. Here they told a convex mirror, they told no. So it will be positive. Focal length, you have to take it as positive. Convex mirror means positive you have to take. That means it is positive. Positive. So he'll get 13 here. So 13. So 13 means 50. So 50. So I have to erase this. So what you'll get? You will get 15 by. So you should get a positive value. So you always get a positive 15 by 30. I thought it as a concave mirror. So convex mirror that one. Okay. So 13 by 15 means 13 means first 13. 15 means 1's are 13. Okay. Then 2. So again 1. So 1.1 something you get. So 1.15. So 1.15 only you get. 1.15 you get the value. So 1.15 you should get. So let me draw the ray diagram. So you will get 1.15. So for both concave and convex mirrors, you have to use the same mirror formula only. Okay. So let me draw the ray diagram for this. The object is placed at a distance of 5 meters, no? It is 1.5. It is 1.5. So you should get in range between. So you should get in the range between 1. So you should get the value less than 1.5 only, because it is found here, no? So in the exam, if that what is the range means, you should tell that it is less than 1.5. In the less than 1.5 range, it should get the image. Okay. So here also they are also asking about the what you say here they are also asking about. So what we have got the value 15 by 30, no? So if you want, you can keep it like that only. So no need to convert it to decimals also. You can just keep it like that. So let us try to find positive. Now let us try to find the height. So magnification is equal to h1 by hi by h naught equal to minus v by u. So minus v value what? I am taking 15 by 13 only. Minus by u value what you got, 5 you got. So 5 3s are. So final value some 3 by 13. 3 by 13 means you get 0.23 minus 0. Plus u value is minus will cancel, so plus 0. So 0.23 will get the magnification. Why we get less magnification, less than 1? So you have to remember the magnification. Forgot. Magnification is actually magnification is greater than 1 means image is magnified. Magnification is less than 1 means image is small. That means it is diminished. The magnification is equal to 1 means image is of the same size. Okay. Next question will solve. So the height they gave. So height of the object is 4 centimeters. Okay. Okay. Then next what they gave. Placed at the distance of 20 centimeters, 25. So u is minus 25. So u will always be minus 25. I can easily remember. Concave mirror. So focal length is also minus 15. The focal length will always be minus only. Okay. In concave mirror. The wall distance. So we should find it. Okay. So 1 by u plus 1 by v 1 by f. 1 by 25 plus 1 by 1 minus 1. Sorry. It's kind of mistakes, no? Okay, I'm shifting this side. plus it will be. So 15 and 25 LCM, what you'll get? Quickly tell me. Okay, 75 you'll get LCM. 75. 5 is 3 is. So minus 5 plus 3 by 75 minus 2 by 75. So V value is 75 by 2 minus 75 by 2. That means 37.5. So minus 37.5 centimeters will get. Okay. That is the value. That is the value of actually that is the value of this. Okay. That is the value of the image. That means minus 35. That it is from the mirror. It is 37.5 centimeters. Okay. Okay. Now let us try to see. Let us also draw the image of for ray diagram. So see. So focal length is 15. So this is 15. This is 15. So where the object is at 25. That means here it is placed. Okay, because this is total 13, so it is placed between. So it is between C and F means where we'll get the image will get beyond C. Beyond C means the length will be more than 30. That is the perfect thing we got. Okay, we got it more. So we will get more than 30. So perfectly. And the image also the height of the image also will be greater than 4 centimeters because this is smaller and this will be the greater one. That also you should remember. Let me check the answer for 37.5 only. 37.5 minus 37.5. So if you take magnification, so magnification M is equal to minus H1 by H0 minus V by U. So magnification is not given. So HI you have to find out HI. So 4 equal to what is the V value you got? Well, minus 37 by, or else you take minus 75 by 2 won't be easy. This U value what you got? U value U is actually given in question note minus 25. So minus cancel 1s are 3s are. Okay. Then HI equal to 3 by 2 into 4. So 2 to 4. So and also one more minus is there because minus 75 by 2 is the actual value minus value and one more minus is also there. So minus 6 will get. So this is the answer, perfect answer. Yes, we got it. Okay. Let us solve the question. Okay. The focal length. We have to find the focal length. Radius of curvature is 32 means 32 by 2 means 16. So 16 is the focal length. Okay. Then concave mirror produces 3 times magnified image of the object placed at 10 centimeters. 3 times magnification is 3. Then object placed at 10 centimeters. So they gave it as 10 centimeters. So minus V by U is equal to M, no? So we have to find V M minus N equal to 3 minus 1. So V equal to 30 centimeters. Here the image concave they told. So concave means magnification. They told us 3 times magnified, enlarged image. That means it will get us image is 30 centimeters. That means they're asking where the image is located. That means location of the image is very much important. So where the image is located here, tum bata. That means 20 focal length. Okay, we have to find the focal length. So you have to do the focal length and we have to find it. So let's do it. Minus 1 by 30 plus. You got a plus, no? Enlarged the 2. Let us take a plus only. Okay, plus then minus 1 by 10. Okay. And 30 it means okay. So I think the meeting is going to end quickly. minus 15 will get minus 15 centimeters. So minus 15 centimeters मतलब का minus 15, so object is 10. Object is 10, so image is 30. Focal length is 15. तो बताओ. Ended. Gone. Object is 10. Focal length he got 15. कैसे है? Image is formed at center of curvature. Oh, some mistake we have done here. Let me actually do it now. Okay, let me do it and let me give you the final and confirm answer. You just stay on line only, then you can get the answer. Okay, so let me do it now. So magnification. So magnification m is minus plus 3 only they gave. Okay, plus 3 they told. Then so for the concave mirror they told. Concave mirror means magnification always in minus. You have to remember. Minus 3. Okay, minus 3. Okay. Then the u value is minus 10 centimeters. Then v value is, you have to find. So for what you have done, minus v by u. So it is minus v by minus 10 equal to minus 3. Minus 9 cancel, so v equal to minus 30 we got. So v value we got minus 30. Okay, fine, minus 30 we got. Then minus 1 by 30 plus minus 1 by what we got? 10. 30 LCM, no? Minus 1 minus 3 by 30. Very galat. Let's check. Let us do till our final answer, till we get final answer. I'm getting minus 7.5. Let's check in Google whether this answer is correct or not. How many views you got? How many 2 you got? Very bad. It's fine. It's 1.5 it should be, otherwise 30 we got the answer. 7.5 we should get the focal length. So where the image is located. So that means let us draw the ray diagram. And draw the image now. U10. Okay. Focal length is 7.5. 7.5. Then image is at 10 centimeters. So okay, we will get beyond C. So beyond C means it will be 30 centimeters. Perfect. So we got the images located beyond C. Actually, some confusion happened. It is located beyond C. Sorry. Creating you all also confused. So for making you all also confused. Okay. I'm really sorry for making you all confused. Okay. So first you have to do everything. You have to find image, you have to find focal length, and then you have to draw the ray diagram. Then you can actually tell that. Okay, without drawing the ray diagram, tell it. Okay, so that's it. Here we actually come to the end. Let me check if actually I have done it, so I will also get a clarity. Now done. Just you can tell it is looking in front of me. Okay. So with that we complete the reflection part. Okay. So reflection part is successfully done. Okay, then in the next part you are mainly going to see about the refraction, everything, all problems, sari part of the lens, everything. Okay, then